Hello everyone and welcome to another episode of Knowing the Product Better. This is a series where we break down industrial products in a way that actually makes sense. Whether you're an engineering student, a working professional, or just someone curious about how things work behind the scenes. Because let's be honest, when we hear terms like PLC, automation, or control systems, they often sound complex, but they don't have to be. So in this episode, we are going to talk about one of the important components of industrial automation, the PLC, often known as Programmable Logic Controller. We'll understand what it is, how it works, and where it's used and why it plays such a crucial role in modern industries. No complicated jargon, no heavy theory, just simple practical understanding. And to make this even simpler, I am here joined by Nitin Mahajan, Product Manager, GIC. Hi Nitin.
Hello Sally, thank you for having me here.
Let's get started.
Yeah.
What is a PLC and what is its important in the industrial automation?
So basically PLC is the brain of the machine. PLC is a programmable logic controller. It helps to automate the processes by taking the feedbacks from the field like input signals from the sensors, auxiliary contact, and it may process the signals in the CPU as per the program, and the PLC gives the outputs in the field for the valves and to automate the motor commands. In a simple word, it replaces the manual work and makes machine run automatically.
So basically how brain works to help the body part function, PLC helps the machine function.
Same as it.
How does a PLC works in simple terms?
Yeah, so basically PLC works in a loop system. So first of all, the inputs coming from the field and that inputs going to the CPU and CPU processing that inputs, and after that CPU giving the outputs as per the logic sequence. So this is the loop system and it's continuously running in the CPU as per the program.
So it's a constant functioning that happens in the back end of any machines.
Yes, that is the continuous process.
Okay. Why are PLCs used instead of traditional relay-based control systems?
So basically earlier the customer was use the relay-based system. That is a completely hard system and it's taking too much space in the panel. Also there is a complex wiring inside the panel. So PLC makes things easier. You just change the program instead of rewiring everything. So they are very faster and more reliable and much easier for the customer to maintain their system.
You explained PLC in much simplest way. So when we talk about PLCs, can you explain what are the different components in PLC systems?
Yeah, very good question. So basically in the PLC there is there are some components, but out of that components the one main part is the CPU, central processing unit, and remaining is the input module, then output module, then communication interfaces like serial connectivity, Ethernet connectivity. Then in some PLCs there is a SD card connectivity support. So like that components are very important in the PLC.
And why these components are important in the PLC?
So these parts help the PLC to sense the input, output, to process the logic, and gives the output to the system.
Thank you for the information.
Okay.
So you talked about input and output system as a PLC component. So can you briefly explain what are these inputs and output in PLC and why they're important?
Yeah. So basically input and output, these are the very two important component in the PLC system. So basically inputs are coming from the field like from sensors, then some auxiliary contacts, and PLC processing that input signals and giving the output command. So output, in the output form, PLC giving the signal to the valves, then some actuators, some motor start command. So like that outputs are coming from the PLC to generate the output.
So basically it takes inputs from system A and gives output to system B to function better.
Yeah, yes.
Okay. Moving on, can you explain PLC scan cycle and why it is important?
Yeah, the scan cycle is the PLC's working cycle. That is a very important parameter of the PLC because PLC's complete response time is depend on the scan cycle. So basically scan cycle is calculated by the program, how much program you have developed in your software and you have downloaded into the device. So scan time is depend on the programming, how much type of logic you have developed and what is their complexity. On that basis PLC scanning the all rungs in the logic. So basically PLC scanning from left to right and top to bottom like that concept. So that scan time it's depend on the program, and whenever your scan time is good, so definitely you will get the good response from the PLC. And the scan time basically is in the millisecond or microsecond. It's depend on the PLC type.
Okay, and it's inbuilt in the PLC product itself?
Yes.
Okay.
This is a parameter of the CPU.
CPU. What is ladder logic and why it is widely used in PLC programming?
Yeah, so basically there are multiple types of programming platform in the PLC software. So ladder is the one programming language. Except ladder, there is a FBD programming, then a structured text programming. So there are multiple languages which are generally customer using to develop the PLC application. So ladder is the very important or favorite programming language because it is very easy and simple to understand to the user or customer. That's why most of the customer preferring to use the ladder logic.
So any specific feature that you would like to explain more about ladder programming?
So in the ladder means those are from the electrical background or from maintenance background. So they will easily understand the program because there's a NO contact, NC contact. So like that ladder is there. So it is very easily understandable in the contact format, like a NO NC format and the coil format.
So you mean to say ladder programming is very easy for mass audience use,
Yes.
which do not understand complex programming and
Yes.
are not habituated to those.
Yes.
Great. Going on, so what is the difference between digital and analog signals in PLC?
Yeah. So basically digital signals are just on and off condition. So that is in the form of the on and off only. And if you talk about the analog signals, you will get the actual value of the sensors. So in the field there are multiple sensors like a temperature transmitter, a level transmitter, level switch. So level transmitter will give you the exact value. What is the level right now, 50%, 70%. So that is the exact analog value that you will get into the analog signal. And in the digital form you will get only the on and off condition. Key level is met for the high level. So you will get the 0 or 1 input. So that is the digital.
But does PLC have both these system inbuilt, digital and analog, or
Yes.
it differentiates from product to product?
Yeah, so basically in the base model, most of the PLC supporting the digital input, then some PLC giving the analog input also. So it's depend on the sensor, what sensor connected in the field. So accordingly, customer will connect the input to the particular model.
Great, that was good information.
Yeah.
So we have understood a lot about PLCs, the product, its programming, functioning, its components. Now we would like to understand which all applications and industries these PLCs are widely used.
Basically, PLC is required in every segment or industry because whenever customer required to convert their manual system into the automatic system, so in that case definitely they require the PLC. So if you talk about the segment or industry, so majorly customer using for the machine industry, then packaging industry, water segment, HVAC segment, so HTLT segment. So in every segment, most of the customer using the PLC to automate their complete system.
So we understand it's widely used in almost all kind of industries where you need a programming support to understand the functionality of any machines.
Yeah.
So how do PLCs improve efficiency, reliability and automation in the industrial processes?
So basically PLC reduces the human error from the system. Also it increases the productivity. If you run the system automatically, so continuously you will get the better productivity from your system, and which reduces the downtime also. That will also beneficial for you to increase your productivity. So in short, they make systems smarter, faster and more reliable.
Thank you, Nitin, for sharing this insightful information about PLCs.
Yes, thank you Sally for having me here.
Thanks for tuning in to Knowing the Product Better. We'll be back with another product and another simple conversation. Until then, keep learning and keep exploring.